model. Now this is the model that I have got. So I have estimated B and A. So I got the equation. Let's say y cap. In this case, it is 1 into x plus 0. So this is the equation that we have got. And then what we do, we actually then predict the or the estimate the values using the model. Okay, what do I mean by that? So this is the target. This was the target. Now I will find out y cap for given x value. Okay, so if x is 0, I will get from the model, because I have got say model as y cap is equal to 1 into x plus 0, right? So I will get, for 0 I will get 0, for 1 I will get 1, 2, 3, 4 and say 5. Okay, I'm ignoring this last sample. So for all this data I am getting exactly this. Okay, so this is how we estimate the new values. This is nothing but predicted values. And then we find out the error. So error could be simple residue like this. Okay, predicted values and difference between predicted value and target value. So this could be a simple residual error. And then we find out the mean error. Okay, so here if I find out the error, what will be the error? Y minus y cap. For first sample it is 0, for second sample it is 0, for third sample it is 0. Okay, so everywhere I am getting a 0 error. So if I find out the mean of this y minus y cap, okay, divided by number of samples, okay, let's say m samples are there, then you know that this also comes as 0. So since I am getting 0 error, I have to stop there. So my line is completely fitted, you can say. Line is completely fitted. Yes? Got this? Yes, very quickly. Yes or no?
Yes, sir.
Yeah. Please answer quickly. Otherwise, we are wasting so much time. Otherwise, I will have to leave. I will have to. I mean, decide. I mean, what to cover. I may not be able to cover each and every point there. Try to understand. I am expecting very quick response from you people. If you are not understanding, please let me know. But if you are understanding, please respond also, so that I will come to know. Otherwise, I will keep on repeating the same things many times. Okay. So let me show you this simple exercise in the MATLAB. You can do it in the uh, Python also, doesn't matter. Very simple program. So look at this program. X is this 0 to 5, y is 0 to 5. Okay. Just this is converted into row vector, converted into column vector. This is also converted into column vector. So transpose is taken. Then we can find out the mean. So there is a mean equation, mean function. I can find out the x mean and y mean. Okay. Then we have to subtract x minus x mean, y minus y mean, and find out the covariance. Then find out the variance. Okay. And covariance divided by variance, you will get the first parameter of the line, that is slope. And once I get the slope from second equation, I can find out the y-intercept. Okay, right? And once you find out this y-intercept, you get the new model, that is y cap. Y cap is equal to this, say, ax plus b. Okay, and then you can find out the, or you can display the line which is fitted. Okay, so let me run the program. So here you can see the estimated parameters. Okay, so intercept is 0, slope is 1 as expected, because we have completely taken the points which are exactly matching with these values. So x and y values are same. Okay, so you got the perfect fitting line. So this was the data points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And that's why we have got the line which is completely fitting to this. Now, given any new value, okay, given any new value, so here suppose if I take the value as 3.5, okay, and then I can use the model now, okay, and I can find the value. So from this point, this equation, y is equal to x, y cap is equal to x, I am getting the value as 3.5. So this is how we can predict a new value, which we call it as a regression. Okay, so this is simple line fitting program, line fitting, or you can say linear square, least square fitting. Least square means you are actually finding out the square distance, okay, Euclidean distance, and trying to optimize the line, trying to fit the line, trying to fit the model to the given data points. But what is the problem with the model? So going back to the slides, suppose I have a noise in the data. What do you mean by noise? We have seen the definition of the noise. What is the noise? Noise is any sample value which is wrongly recorded, isn't it? So by mistake, during the recording of this sample values, as you see, for x is equal to 10, actually the data the target was expected as 10, but for 10, the target is say 2. So there is a mistake. So this is called as noise or noisy data, or this is also called as outlier. Okay. Now what happens in the line fitting or least square fitting? In least square fitting, the technique is not that smart to eliminate such noise points or such outliers, but the algorithm will try to fit the line to each and every sample, and that is the problem. So what happens here is, if I have such noisy data, okay, look at this point. So once I add this sample 10 to, okay, what is happening is my entire fitting of the line, that means the line equation, the parameter estimation goes wrong. So these are the 5 points to which this line was best fitting, but because of only one outlier, because of only one data point, the entire model is changed. Entire parameter estimation is wrong, and that is the problem. So that's why nobody goes for least square fitting method, because it doesn't take care of the outliers. So there are so many advanced optimization techniques nowadays, okay, which you can use and which we are going to see later. Especially in deep learning, you have very nice optimization algorithms. Okay, so we are going to look at this. Okay, so hope you understood the uh, LSQ method, that is least square fitting, and how basically a model is defined, how we estimate the parameters, what is the effect of the noise. All these points you must have understood. Yes. So in gradient descent algorithm, our objective is come up with the value of the theta, the parameters. Let's say in this model, there are two parameters, theta 1 and